Hello, hello. Hello, hello. Okay, so hello, I am Olivier Matz, working at Sixwind. I will talk about the Mbuf. So I think everybody knows Mbuf here. It's a structure in DPDK that represents a packet, a network packet. It's a core DPDK structure, and I will also talk about the mempool, which is a structure that stores the Mbuf to allocate and free the Mbuf. First, please sorry for my poor English. If you have a question, please speak slowly and take your best French accent so I can understand. Okay. So let's see the plan. So I will first summarize the first two parts. It's a summary of the recent changes in Mbuf and mempool in 1607. The second part is the new features that will be introduced in next version that is coming. And the last part is more a discussion. It's not a presentation, but I will stop at several steps, and if we can discuss ideas, and I will take some notes so we can conclude maybe on some subjects. Okay, so the first new feature in 1607 is a big change in mempool memory allocation. So since this version, we can now allocate mempool in fragmented memory. When you start the DPDK with a 2 megabytes huge page, the operating system is not able to build a very large amount of contiguous physical memory. It can only guarantee that the physical memory is contiguous for the 2 megabytes of the huge page. So now the mempool is able to be fragmented and create objects in these fragments, and this allows to reduce the amount of panic when you start a DPDK application with 2 megabytes huge pages. It also provides a new API with less arguments. So the advantage of this is we can now don't have 15 arguments to create a mempool. You can just create, populate, initialize objects. And if we want to add new APIs, like I will talk just after that, mempool handler is now a new function that does not break the API of mempool creation, mempool object initialization, etc. Also, with this change, we can now free a mempool. So maybe it's not very useful for packet, because usually the packets are living as long as the DPDK application. Maybe with hot plugs, we can allocate a new mempool for new drivers or new NICs. And it is also possible to allocate mempool outside huge page memory. This was a feature already available in TestPND, but now it's in mempool core. So even if you start the DPDK with no huge, or you can create a mempool inside it, or you can mmap a zone by yourself and populate the mempool with this zone. And another point which is not here, I heard this morning someone talking about resizing pools. So I think with the new API, create, populate, I did not test it, but most of the work is done. If you want to add a new object in a pool, it may work. Just
talk about that different thing.
Ah, okay.
Maybe after.
Yeah, okay. So another change in 1607 is mempool handler. So it was done by David Hunt. Don't know if he's here. Yeah. So previously, a mempool embedded RT ring to store the object. So mempool, it's a per-core cache and a ring for common objects. With this new feature, it's not. We can change a ring and replace it by something else provided by the user. So a new API has been created to register a new pool handler. For instance, the stack helper that was added at the same time that this feature. The per core cache stays the same, so there was no modifications on the per core cache, which is already a stack per core. And this feature opens the door for hardware-assisted mempool handlers. So we will talk about this later in the discussion. Another feature is a user-owned cache, so done by Lazaros Koromias. No, not here. So I talk about the per core cache. When I say per core, it's not per CPU core, it's per EAL thread. So each thread of EAL has a L core ID. And if you want to, before this patch, if you wanted to use a mempool from a piece thread you created by yourself, you are not able to use this per core cache because you have it was embedded in the mempool and you cannot use it. So it was not very efficient. You had to use directly the command ring, and it's not very efficient to enqueue and dequeue objects. So a new API was added to create a local cache and use it when you enqueue and dequeue objects before using the ring or the stack or the handler. Just a side note, the ring still requires that the threads are not preemptible. It means that so EAL threads have some constraints. They are locked to a CPU, and they are the only application, the only process running on that CPU. If you create a piece thread which does not match these constraints, it can be scheduled by the kernel, and it can freeze the enqueue during some time. So it's still not perfect for now if you want to use a mempool from an external piece thread. Maybe we'll talk about this also after. So this was for mempool. In 1607 there were few Mbuf changes. So a minor one is the raw Mbuf allocation that became public. The raw Mbuf allocation is a function that is called by driver. So before, every driver copied this function in its code and then called a private function. So the code was factorized, and the raw Mbuf allocation is just a function that takes from the mempool and sets the ref count to 1. New RX flags were added for stripped VLAN because all the NICs were not behaving exactly the same. IXGPE and ForgeVille were not behaving the same. So a new flag was added saying the VLAN has been stripped and the ID of the VLAN is inside the Mbuf. And last thing added is some prefetch helpers to prefetch the Mbuf metadata, the Mbuf structure, so which is split in two parts. We'll see that. Prefetch the first part or the second part. So what's coming now in 1611? So about the RX checksum flag. So before in DPDK, we had only one flag saying the checksum is bad. So if you have the flag, the hardware tells you, okay, the checksum is bad, you can drop the packet or do whatever you want, but the checksum is bad. And if you don't have the flag, you don't know. Maybe the hardware knows it is good because it is not bad, but maybe the hardware is not able to know if it's good or bad, and it's unknown. So to solve this problem, we have to add new states. So now we have 4 states. So the first state is bad, the second is good. Okay, so the hardware is able to recognize the packet and say the checksum is good. And you don't have to check it. If the third state is unknown, so you have to check the checksum by yourself in the software. And the last state is useful for virtual drivers. For instance, if a host sends a packet to a guest, the host won't calculate the checksum because it costs time. It will just leave it empty or set a pseudo-header checksum inside of it. And the guest will receive the packet with a wrong checksum in the packet, but the guest knows that this packet is valid because it's just memory shared between the host and the guest. So this last state is a way to say, okay, the checksum is maybe wrong in the packet, but the packet is valid. And if you have to transmit this packet on a real NIC, you will have either to calculate it in software and set it in to the correct value, or to use TX checksum in hardware if the NIC supports it. Okay, another feature is the software packet type parser. So the packet type is a value inside the Mbuf structure that describe the type of the layers in the packet. For instance, it says the layer 2 is Ethernet plus VLAN, layer 3 is IP, layer 4 is TCP. So some drivers are already able to set this packet type, so the application can use it and accelerate the parsing of the packet, so without looking inside the data. To provide a reference implementation, in addition to the documentation, we added a software parser, which will check inside the Mbuf data and return the packet types that should be set by the hardware. So you can compare the software value and the hardware value and check that the hardware behave correctly. And this was added not only for debug, but also for Virtio RX offload, because in Virtio protocol, you only pass the offset of the checksum and where you start to do the checksum, and the offset where you will store the checksum, and there is no information that says it's TCP, it's UDP, or it's whatever protocol. So it's more generic, but the DPDK API currently requires to know when you say, okay, the checksum is valid and it is TCP. So as we don't have the information when we receive a packet from Virtio, we have to use to parse the network header to see if it is TCP, UDP, or something else. Okay, and some other minor Mbuf changes. A new API was added by Maxime Coquelin to reset the headroom of a packet, which is used in the Mbuf layer, and it can be used in application to recycle Mbuf. A new API was added to read the content of a packet safely. When I say safely, it is so the new API is called RT Picati Mbuf read. So you have a Mbuf chain, and you want to read data. So you never know if you want to read across two segments. It's dangerous to access because it's not contiguous. So this API, you give it an offset and a length. If it is contiguous, it will just return the pointer inside the Mbuf data. If it is not contiguous, it will copy the data in a buffer you also provided, and you can access to it more easily. So you can map a network header very easily. And this is also used inside the software parser. Last point is added by Jianfeng Tan. It's new TX flags for offload in tunnel. So now you can ask for TSO inside Genève, VXLAN, or GRE tunnel. Okay, So that's the end of the first part. Now I will talk about several topics, and if you have questions, you can just raise your hand. Yeah.
You were talking about using new flags for checksum, right?
Yeah.
But if you take a look into that one, actually, is this something what you need to do for every single packet, or you can basically just have an API which will tell you this driver can do this or it cannot do this?
Could you speak slowly, please? Sorry.
So you are changing the flags here, right?
Yeah.
And what you are giving now is information which is basically persistent. Yeah. So if the driver is able to do a checksum check, it can do it for all packets, right?
Yeah.
So is there really a need to yeah, but the point is, driver can do, I mean, instead of consuming more bits and changing the layout in Mbuf, why we just cannot have an API saying, please tell me your capabilities. And if you give me back information, I'm not able to do checksum, that's fine for me. I don't need to have that flag in every single Mbuf.
Well, imagine you have a machine with one NIC with many features and another NIC with a few features. And you will get Mbuf from these two NICs, and both will enter the stack, and maybe you will want inside your stack to check the flags. And you may not want to ask to the driver, the underlying driver, or do you support this feature? You want to have the full state inside the Mbuf, inside the stack. No?
Yeah, but still, I mean, there is a cost of parsing every single bit, right?
Of parsing?
On the code, which is taking the burst from the NIC. You need to basically check flag for every single packet. And handle all these cases which you have here, right? So it will increase the cost of processing the burst of packets.
Before, you had to check. You had the same number of states, bad, or something else. And how do you differentiate this something else? You had to.
It's not checked. Yeah. But I mean, my point here is that it's not only about this, but generally, I would like to really have the information from NIC, from driver level, what driver is able to do and what it is not able to do.
Yes.
And I was really thinking more about having the API which will tell me that, so I can keep my state in my application instead of really checking every single Mbuf for this.
Yeah.
So, yeah, there is such API, you can do that now, kind of.
Yeah, and I was just going to say that I don't think the two approaches are mutually exclusive. I think it's good to have both, because if you want to write a library that's reusable across applications that takes in Mbufs, it's good to have these flags there if it needs them, because then it comes up with every Mbuf, it can be checked. But if you've got an application that knows that it's taking packets just from two NICs and it can query at initialization time what are the NIC capabilities, it can then take shortcuts to check these. But just because these bits are available doesn't mean that every application obviously has to check on a packet-by-packet basis if for that app checking on a driver basis would work. The other wrinkle in this is if you look at NFV type world and you start looking at things like link bonding, migration of VMs, the underlying hardware and hardware capabilities may change, in which case you really need this stuff on the Mbuf to do it on a packet-by-packet basis. But as long as we got the NIC API as well, then your scheme should work too, and that may well be faster indeed for a lot of applications. But that doesn't mean that we don't need this as well, I think, is my opinion.
I guess the question is, who is doing this? Who is setting and clearing these bits? Are these bits being set and cleared or parsed in the PMD, or is it the application?
Yes, the bits are set by the PMD and are used by the application.
Yeah, a question on the packet type API. So my understanding is that right now we try to kind of create an exhaustive list of all the packet types that exist on the universe, which is one approach, maybe not the best in my opinion. Is there any plan to actually define only the packet types that we need for a particular application. Have the application define that. So for example, say, okay, I only need 4 packet types, and packet type 0 is TCP/IP, packet type 1 is MPLS with whatever, and 2, 3 are whatever. So these are only packet types that I care, discard all the other packets rather than have a million packet types. Is there any plan for this?
Yeah, it's not the packet type in the Mbuf structure, but something was proposed by Adrian. I think it's more flow director. You can tell the hardware to filter this kind of packet and tag it or send it to a specific queue, and you can have the same feature, and it's dynamic. So your application will register a different match, and we'll process it in different queues or have some tags. You can duplicate packets in different queues. So it's flow director. It's part of another API which is in ETH dev.
Okay, thank you.
Sorry, so a related question, I guess, but much higher level from the networking usability perspective. Isn't it as simple as either we trust the driver and we either take the packet if checksum is good, or drop the packet if checksum is bad, or if the checksum is supported in the driver or in the NIC, or if the NIC can't do it, then there is no checksum checked and I process the packet. That seems to me much simpler than going through the different states.
Sorry, please can you repeat the end?
Okay, so every packet checksum should be checked.
Yeah.
Okay. If it's not checked, then there is an issue of all sorts. So I want to know what I'm dealing with. So I negotiate with a NIC that the NIC is capable of checking the checksum. This is a contract. I trust what I get back. If the packet is checksum is good, I basically process the packet. If checksum is bad, based on configuration or whatever default setting, I drop the packet. So 2 states.
Okay.
And then so this negotiation to Damian's point, and if the NIC is capable of doing the checksum, if the NIC is not capable of doing the checksum, I have to do it.
So maybe I have two comments on this. Maybe some hardware are able to calculate the checksums on some packets, but let's say you had a VLAN. It will be able, or you have double VLAN, it will not be able to calculate the checksum. And in that case, what do you do? Do you have to know in your application that if it is VLAN or double VLAN, it will not be checked by the hardware, or if it is fragmented, or I don't know, maybe some kind of packets will not be recognized properly by the hardware. And also, as I said to Damian, if you have several ports, I think inside your application, it's difficult to retrieve from the port ID the information of, this NIC is able to calculate the checksum and verify it, and this NIC is not able to do it. So if you have the information inside the Mbuf with good, bad, or unknown, you can check the information inside this Mbuf without checking if port ID 1 is able to do the check or not.
So I guess you must have had cases where all of these, the good, bad, and ugly, and number of uglies, are present. So I get that, but still the concern would be if I'm really counting the clock cycles per packet, and performance is one of my sweet spots that I want to go after, and one of the reasons for DPDK to exist is per earlier presentation. I think it should be, at least the user should be able to give an option whether to use this or not. And if this is optional, sure. But the simpler, the better, I guess. My point. Thanks.
Hello.
So, answering to that, actually, my name is Ugesh. I'm working for OVS team. So actually, we requested for this flag for the OVS, So the problem here is in OVS, right? So there are use cases like you may get the packet. In some cases, I mean, that's kind of a feedback we got from the mailing list. You may want to process the packet even though checksum is bad, And also we have cases like, let's say you got a tunnel packet and then you normally check the checksum at the time of when you reach at the tunnel decapsulation site. By the time, you don't know at that point in OVS code where the packet comes from, which port. So at that case, you have to keep track of which port the packet comes from until your pipeline ends, you know. So it's good to have, it's part of the Mbuf itself rather than having an API or something. So that's the reason we requested for this flag having an API, because normally in OVS PMD model, we don't have the information of the port when you reach at the end side, because you already decided what action has to be taken on that packet. So that time you need something on the metadata in the packet itself to decide what's there. So that's the reason we went with this flag approach than the API. Okay, thanks.
Just a question. We are talking about possible regression, but do we have performance numbers before, after?
Yes. So, don't see any performance degradation with that.
Oh.
And thank you for the French accent. Okay, let's continue. Maybe we won't be able to do all the topics, but it's not. We can talk around the beer later. So one topic is Mbuf structure reorganization. So there are several subtopics inside of it. So the Mbuf is a core DPDK structure, so we have to be very careful when we change it, because it impacts performance. We also don't want to change the API or the ABI every 2 mornings. So we have to bulk modifications. The Mbuf structure is split in 2 parts, which are called RX and TX. The RX part is usually filled by the PMD when it receives the packet, and the TX part is filled by the application and is used by the TX part of the PMD. In theory, because in practical, some fields are used in RX are in the second part, because the room in the first part is very tight. So one of the debate is how can we decide if a feature has to go in the first part or not. Another question is, can we extend the Mbuf and add field ad infinitum? And we had an example recently with the timestamp on the mailing list.
On the, so the fields that are in the second cache line that are touched on RX, whenever the rework was being done as part of DPDK 1.8, the reason that those particular fields were moved to the second cache line, not left in the first, was, yes, they're used in RX, but they're used in the slower path RX parts. So it's, just to put that in as clarification, so things like the next pointer is put in there, because if that's needed, you've got a packet that overflows one buffer. If it overflows one buffer, then it's a big packet, so you've actually got more time. You've got a slower arrival rate, so you actually have more time to process the packet. So there was actually some logic behind the move of those particular RX fields to the second cache line 1. The ones in cache line 0 were for the fast path RX processing. So just wanted to mention that as clarification.
You take some advance in the presentation, but that's one part of the debate also. So you see the nnext. In RX function, we need to set the nnext to null, even if it's not set to another Mbuf. You have to write it to null, and this can cost. So this is one problem. Seen for VPP, if I remember well. At least there is a patch in VPP to move the next pointer in the first cache line. Another thing that was seen by Jerin, the rearm marker is not aligned. on some architecture on ARM.
Just a correction on that. And so that patch has been taken out of VPP now. So just here. Je peux parler français aussi.
Oh yeah.
And also that patch has been taken out of the most recent VPP release. It's not there anymore.
Okay.
I'll jump in again and say, in terms of setting it to null, most of our RX functions don't actually set it to null because we have an implied policy which is that it's set to null on free. So whenever it's actually allocated, it's already null, so the drivers don't actually need to touch that cache line.
It's not done. We should do it, but I think it's not done.
It may be missed in some cases, in which case we should fix those. Because I think that's the fastest way to get it performance.
I agree.
Yeah, I'll let you carry on with your talk.
I completely agree. So the rearm, just to explain what is the rearm, it's a marker of, it's a zero-sized field in the structure that is used as an offset by vector drivers to set a bulk of fields in the Mbuf. And one rearm marker is not aligned to 64 bits, and it costs more on ARM to use a vector instruction on it. So it was proposed to move some field so to realign this marker. Another issue that was seen is import and number of segments are 8-bit wide. So it limited the number of ports to 256. One can say it's enough, but I've heard for virtual drivers with a lot of virtual ports, it may be a bit small. And the same for the number of segments. If you want to store, let's imagine in a stack, TCP stack, you store your socket buffer as an Mbuf because it's the most efficient way to store the network packet. You may have more than 256 segments. Another question that was raised is import needed? Because it is set in RX part, but when you call RX burst, you know that you are calling the RX burst on a given port, so you have the port ID. But I had a look in the code, and it seems that the port is used very frequently in examples. Sometimes the overridden by the application and used later by a callback. I guess some other external application also use it, so I'm not very confident in removing it finally. And so we don't have enough room to move the M next, but as said by Bruce, we can set it to null when you freeze Mbuf. So just a reminder about the raw Mbuf allocation. So PMD use raw Mbuf allocation, which is usually a mempool get plus a set of the ref count to 1. So one first problem that has been discussed on the mailing list is it's not very symmetric, the raw allocation and the raw free. So you cannot alloc and call free because it will fail because the free expects the ref count is 0 and the raw alloc set the ref count to 1. So I think it was proposed by Bruce. The idea is to set the ref count to 1 for free Mbufs, which are inside the pool, and same for the Mnext. And this will restore the symmetry. It will also avoid, in the fast pass case, for small packets to set the Mbuf to null on the RX pass. And it will also facilitate the bulk allocation and free because you won't have to set the ref count to 1 when you allocate. So maybe it's better to do like this. So the proposal of reordering with all these points, so is to move the rearm data. So this is part of the batch submitted by Jaren. Change the NB segments and ports to 16 bits, and move the buff len, which was on the top of the structure at the end. So now instead of having 6 bytes left in the first cache, we'll have only 4. that's it. We also talked recently about moving the sec n in the second cache line. So I have no strong opinion for that.
Do you really need segments to be 2 bytes long? I mean, I can't even imagine that you have that long packet, you know.
At least we have the need. It's not a good reason, but
Yeah.
Base and fast cache line is precious, right? So, sorry. So, why to waste it for 1 byte that would never be used really? Let's say if you store imagine you need to access, let's say, segments that is 2000, so you would go through all this list, it would just kill your performance. No one would really do that if they do care about the performance. They would try to do something faster, I don't know, probably a table or I don't know, a skip list, something, but yeah, I just can't imagine. Let's say you have buffers that long and you need to access segments somewhere which is few thousand segments away from the start. The only way to go through it is this, just to...
Yes, but you can have an external structure that gives some reference to intermediate segments if you want to grow the segments faster. You just need it if you want, yeah, you need it just if you want to...
That's it.
Yes, but the point is having a valid Mbuf structure at any time.
But you can split your Mbuf into 2 then, right? Kind of, you can't send this packet with 2000, let's say, segments through the network anyway, right? It's just for artificial purposes and for storing it somewhere, right? Kind of, you can split it into 2 segments, yeah, into 2 packets for limited number of segments.
I hear your argument.
Yeah, I find it strange the number of segments needing to be greater than 256 as well. But on the other hand, whenever I was looking at the structure before, I was trying to work out what we could do with the extra byte, because we'd end up having, if we did keep it at an 8-bit value, we'd have 1 byte stuck in the middle of the Mbuf that we don't have, that's a hole, that's essentially wasted. So the only other thing I was thinking there is, does the ref count need to also be 2 bytes big? Do we have use cases where you have more than 255 references to one particular buffer?
I can imagine a traffic generator that if you fill a ring with clones, it can easily go above 8-bit.
That's such an artificial case. You could dial the traffic generator down to only send 255 copies and then make another copy for the next one. I mean, it's not a real app kind of thing. The only time you get a lot of ref counts is if you're doing some weird fragmentation thing.
Yeah, because I mean that would make it then a straight swap of a 1 byte from ref count to port. So switch them in size without affecting much anything else. That's just around those, the odd bytes here and there. In terms of the timestamp is an interesting one though, that has been talked about.
Sorry, what is
the timestamp field that is mentioned, and I'm interested to hear if you have any thought yourself on that. One thing I'm wondering, looking at this, is is it something that could be overlapped with a sequence number value? Do we have cases where applications need both a timestamp and a sequence number, since you could reorder based on timestamp if you don't have a sequence number? So that's one possibility I see, just looking at the structure up here on the screen.
Yeah, makes sense.
For the number of segments, I think somebody earlier said, so that was somebody from Intel that says, when the hardware is able to do something, let's have the hardware to do it. So when you have large segments, it may be also for hardware offloads to make sure that this can be chopped by the hardware. Regarding the number of clones, if you have a multicast or if you're doing an IPTV system that or duplicate an incoming flow into a number of flows, then you might need much bigger than 256 copies of the same Mbufs because you're duplicating it to thousands. So it's difficult to talk about the individual value of a change if you don't have the actual use case that supports it. It's not just we need more space for this number of ports or this number of... you should better describe the use case that's behind it.
Yeah, that's true.
Right, I've got a question about the next field and the proposed optimization. I'm Maciej Czekaj from SemiHub. So have you done any experiments which is best, whether to initialize the next field in Mbuf filling time in Rx, or whether it's better to initialize the next field when you free it? Because obviously when you free a packet, it's usually cold, and maybe it's not better to touch the cache line which is cold, and in the Rx path, it's very likely that it's going to be hot, so there might be some trade-off, maybe.
So I have made some quick tests with this topology of the structure, and so the performance gain is not very significant. I gain 1.5%, but it's reproducible. For if I do 10 tests with the first topology and 10 tests with the second one, the mean gain is 1.5%. It's not a lot, but it's again. It's
consistent, right? Consistently faster with this change.
Sorry?
But it's always faster.
So regardless of the benchmark, it seems to be always faster to do it in a free function, right?
Sorry.
Okay, so you did the tests, and from the test it looks like it's always faster to do it in a free function. And the tests were test PMD? Or?
Yes, it's a test PMD, simple with IO forward.
Test PMD IO forward, okay. Thanks.
So one of the things I wanted to get to was if you believe that the number of ports is greater than 8 bits, then you have to believe the ref count could be larger than 8 bits, because you may want to broadcast that packet to all the ports in that field, right? So you have to, you can't make one or the other, one 8-bit or one 16-bit, unless you come up with that conclusion that you will only ever send a broadcast, format's broadcast to 8 bits worth of ports at a time. So you have to take one or the other.
That's a good point, I think.
Port at all. I mean, it wouldn't represent you every, let's say right now we have port ID which is 1 byte and we have QID which is 2 bytes long. So even if you want to know from where this packet comes, you probably need anyway not only the port number but the QA number too, right? Kind of that would you be interested in that case 2 bytes is not even long enough. So yeah, my personal opinion, just get rid of it from the Mbuf and
yeah, I tried to remove it from the Mbuf, and really it's not that easy. It's used in a lot of examples, and if I want to remove it, it will break a lot of DPDK examples. Let's in a pipeline or in a load balancer, I think it uses the port to save the T export. You don't check in detail, but it's used at least.
But then it's not used in the Rx part. It's about, again, about the port number. If it's, I was thinking, in the ingress, you know what port you're pulling from. So if it's only used in the examples for example cases, then it should be reconsidered for being removed. So I think it's a valid question to see, is it really used in the ingress part? And is it really used out there or only in the examples? Because they might be used in the examples to show what can it be used for, but if nobody's really using it, it's a lot of space to save in a precious part of the Mbuf. So that's one thing. The other thing is the ref count. Someone else mentioned that the Mbuf might be cold. when it's freed, so it could be expensive changing the ref count on free. So I had an idea about instead having, also you said it needs, the driver needs, it sets it to 1 when it's allocated, and you need a symmetric function to free it. I was thinking instead of having offset 0 for the ref count, so it's 0 when it's not allocated and 1 when it's allocated for the first time. How about having offset -1? So when it's free, it's in some pool. When you allocate it the first time, it's 0. It's also easier to zero it out than setting it to 1.
I mean, what's the difference? You kind of to freeze and buff, you first have to check the reference count. To do the check, you have to read it. So it means that it would be in the cache line, your reference counter. Otherwise, you just can't free it. You don't know what the value will be. Maybe it used.
Exactly. Yes, I agree. But when you allocate it, you don't need to touch it again. Then it's already 0. It means it's allocated once.
You mean keep it at 0 all, kind of set it to 0 by free? That's what it's doing now, I think. When you freeze it, you set it to 0. Yeah.
Yes, but you say set to 1 on the allocation.
No, that's what is done today. Today, when you allocate Mbuf, the ref count is set to 1.
Yes, and I suggest setting it to 0 when you allocate it, because then you don't need to. It's easier to set it to 0 than setting it to 1.
But as long as you have to touch it, it doesn't really matter whether you choose 0 being a single reference or 1 being a single reference to the buffer. Because the fact is, it's constantly pointed out, you're going to have to touch it, at least read it, if not write to it on free. Be it that you said 1 is largely unused or 0. So in that case, you're going to be touching it. And you probably want to, in a lot of cases, you may well write to it as well. So if you're going to set it to 0, set it to 1, I don't see that value actually mattering. In terms of the next pointer, on free, that's going to be pretty cheap because the thing you use on free is to write the Mbuf back to the pool, and the pool pointer is also on that second cache line right beside the next pointer. So that's going to be cache hot anyway whenever it comes to free. But if we're going to not set the ref count on alloc, so that we don't clear it, we don't set it to 0 whenever we free back. We leave it at 1 whenever we free, so that it's 1 whenever it comes back out of mempool. Maybe the ref count could then be moved to the second cache line as well. And from the previous discussion, port. So in that case, you could actually free up 4 bytes inside that cache line 0 by moving both port and ref count to the second cache line. And get a good savings. And you also then would have to adopt a general policy of zeroing fields on free, or resetting fields on free. You'd reset the ref count, you could reset the number of segments, reset the next pointer, and so on, to try and speed things up then on the RX path.
You said also the port? Or I didn't...
move the port to the second cache line. Given what's been said here, it seems like it's not really used on alloc, and people, whenever they poll a port, they know the port that they're polling, so if they do want that value, they can write it in themselves. But anybody who doesn't use that field doesn't need to have it in cache line 0, because it's mostly used by applications in a pipeline to indicate further on down a pipeline where this is actually going to be set to. So that would imply it's more a cache line 1 field than a cache line 0 field.
I'd like to comment on this because in our case, I work for Metronome. We are interested in the port field, so indeed we are really happy for this field being now 16 bits instead of 8. So in our case, that is something we need and something that our clients are demanding.
So I'd like to up-level one stage on this. A lot of what we're talking about in the Mbuf are fields that are very specific to an application domain, and it's just because DPDK is a one unified thing that the examples have bled into using metadata in the Mbuf. And if you look at other applications, I know the vRouter and I know VVP both end up doing metadata themselves in parallel to the Mbuf because they're not part of DPDK, they can't go shoving it in, so they end up building a generic metadata mechanism. I think that we should give special dispensation to the examples to go bleed metadata into the Mbuf. The port and the sequence number and a bunch of these fields are that. We should have a real part of a library of example of here's how to do metadata and support that. And the example should use that and pull all these fields out of the Mbuf. They shouldn't be there because the Mbuf should be really generic and focused on the hardware side, not having, you know, the port value and the sequence number and, you know, I would even argue some of the VLAN things might be the same way. You know, hit on the hardware side, stay away from the, I'm building an application, I need to keep state in the Mbuf to pass it around. Do something else for that.
So you mean having this information inside a sort of metadata? Or
well, usually what most of them end up doing is using prepended areas in the data part of the Mbuf to go stash their things. But figuring out a good solution to that that's cache friendly, whatever, would help all those applications, and we would have a general model. And also, you get the problem that because there's no general model for metadata, everybody invents their own, and then people start clashing with their definitions of metadata.
Okay.
Maybe I will agree strongly with Steve, and for instance, VLAN, we clearly, I mean, I don't understand why VLAN is in the Mbuf, because why not an MPLS tag or something else? Yeah, so, but even if we, you say if we look beyond, I know on ODP, for instance, they did try to abstract some packet data structures, and I'm wondering, maybe, I don't know if Yarin, you have some more comment, but some SOCs have some capability to directly provide some packet descriptors, and then my big concern is what will RT-Mbuf looks like when we will want to be very efficient on SOCs. Like, for instance, on Octeon, we had the working entries with some fields. I mean, how do we map an RT-Mbuf on a working entry from Octeon? And I'm not talking of the new CPUs that are going out from NXP, from KVM, so, and others in the coming years. So, I think we need to find a way down the road. The question is not is port in the first or second cache line, because some SOC will have some other data structures for packet buffers. That will be more efficient. Otherwise, we need translation layers, and then we'll pay the cost of the translation layer.
Folks, we just need to keep an eye on the time here. So we've a little bit over. Great discussion, though. But have you any?
There are more topics, but so if you want to read the slide, there are some other discussion we can have maybe later. We can discuss on the mailing list, or you can come to see me. Yeah.
Thank you very much. Thank you, Olivier.
Thank you.
Thanks, folks.